Hello everyone, I'm going to play a review game of true and false about the nature of science. For each of these statements, I'm going to explain why it's either true or false and also just give you the answer. With that being said, let's just jump right into it. Science is provable, and there's a reason why I'm starting out with this one first, because I absolutely hate this word for science. In science, we don't prove anything, we support things with data, and it might sound counterintuitive to what you know science to be or what society knows science to be, because we hear that word prove a lot. But in my understanding and my view of science, we don't prove anything in science, because what makes something proved in science? What amount of data? You can say that there is a claim that's supported by evidence and there's a lot of data that supports it, but saying something is proved in science, I just don't like using that word. I actually say that this provable word or prove is a swear word in my classroom. So this one is false. Next one, scientists collect data from the dependent variable. So in this statement, we're looking at dependent versus independent variables. Remember that scientists are going to collect data from the dependent variable, since the dependent one depends on the independent variable. Scientists manipulate the independent variable to see a change in the dependent variable. So this one is true. Pseudoscience is considered a real science. Pseudo meaning false, and science obviously talking about, the portraying of using the scientific method. A lot of people think that pseudoscience is a real science since it has science in the name, but pseudo means false. It's not a real science. This can be like psychics or using the stars to predict your moods. The reason why this is false is because pseudoscience doesn't use the scientific method to support its claims. Here's our next one. Scientific theories can change. The main thing that we want to focus on here is change. This is a big misconception within just society in general, is that people think that theories can't change. And in science, they can. The reason why they can change is they're based on evidence. So if we get new evidence, we get evidence that contradicts maybe some previous claims, the theory will change. And this is a big misconception that I know I tried to really attack when I was in my classroom, is that theories can change based on new evidence. So this one is true. An hypothesis is an educated guess. This should be an easy one for you to kind of guess, because yes, this is true. A hypothesis at its basic level is just a guess. It's what we think might happen, what we think might not happen, but it's just an educated guess. So this one is true. Science understands everything about about life and the universe. So the reason why I have everything underlined here is this should be a big red flag here. No, science does not understand everything, and that's why science is a thing, is because we're always learning something new. We're always trying to investigate what is unknown, but we don't make the claim that science knows everything. That's part of the reason why science is just really cool, in my opinion, is that we're finding out new things every single day. Peer review helps ensure the quality and integrity of the scientific research before it's published. So peer review means that whenever something is published, or whenever something is in the process of getting published, it is sent to other experts in the field, and whenever they read over the publications or the data and the research, they make sure that publication or that research is done properly, all of the data is collected properly, and it helps ensure the quality and the integrity of that science. So this one is true. Theories are guesses. This is one that I hope that you get really quickly. They are not guesses. Theories are established explanations of why things happen or how things happen. Yes, theories can change, but they are not guesses by any means. This one is false. Theories are supported by massive amounts of evidence, and even though they can change, they are still established explanations in science. Making a hypothesis is the first step in the scientific method. This is a little bit like, ooh, it kind of sounds true since we have hypotheses, again, at the beginning of the scientific method. However, this one's false. The reason being is because making observations and asking questions occurs before you make an hypothesis. I know it might sound trivial, but the part here about making observations is really important. You must make good observations before you can make an effective hypothesis, or even a scientific hypothesis at that. This is something I maybe didn't really understand until I started teaching, but making observations is such a crucial part of science. Theories become laws with more evidence. Again, I hope this is really easy for you because no, theories do not become laws with more evidence. Theories aren't better than laws. Laws aren't better than theories. They describe two different things. Theories describe how, and then usually they have a why here, how and why things happen, while laws describe what happens. A theory will never become a law. A law will never become a theory. They describe two different things. Science can disprove a theory. Hopefully, again, this jumps out at you like, ooh, I think we've talked about this before. Yes, science can disprove a theory. However, it needs evidence to do that. So this one is true since science, yes, it can disprove a theory. It can disprove anything. It can't prove anything, but it can disprove things. Last one here. Observations are any data we take with our senses. So think about what an observation is. You're making a claim, you're making a statement, you're viewing something, you're taking data from it. This one is true. Since we're using our senses, and this doesn't have to be our eyes. It can be our nose, it can be smelling, it can be hearing, it can be feeling. When I'm out in the field in Montana doing paleontological work, we actually will use our tongues to lick some fossils to see if they are fossils or if they're just rocks. So it doesn't have to just be with our vision, what we see, or with an instrument or some type of scientific equipment. It can be a host of different things. As long as it's data that we take in with our senses, it's an observation.